In section 3, we learned how to multiply radicals. We're going to extend that now to doing operations on radicals that are contained inside binomials. Most importantly, multiplying and dividing. So example 1a, we've got 4 square roots of 3 plus 2 times the binomial square root of 3 minus 5 square roots of 2. They're still binomials, so chapter 4 tells us to do the FOIL method. So when we do that, do the firsts. 4 times 1 is 4. Square root of 3 times the square root of 3 is the square root of 9. We do the outsides. 4 times negative 5 is negative 20. Square root of 3 times the square root of 2 is the square root of 6. Insides, positive 2 times 1 is positive 2 times the square root of 3. And last, positive 2 times negative 5 is negative 10 times the square root of 2. If we simplify each one of these terms, we will end up with our solution. Square root of 9 is the same thing as 3. And that's all I can simplify in this step. So 4 times 3 is 12. And we'll learn that we can only add radicals if they are exactly alike. Two things are involved there. One, they have the same root index, which these all do. They're all square roots. But secondly, the radicand would have to be the same, which they're not. Square root of 6, square root of 3, square root of 2 are all different. So our answer in simplest radical form is 12 minus 20 square roots of 6 plus 2 square roots of 3 minus 10 square roots of 2. Alright, let's take a binomial and square it then. And of course, please remember that when you take a binomial and square it, you get once, twice, 3 times the trinomial. And there was a formula we learned in chapter 4. And that formula says to take the first term and square it, multiply these two terms and double it, take the last term including its sign and square it. So let's apply that formula to this. We're going to take the first term, 3 square roots of 2, and square that. Then we're going to take these two terms, 3 square roots of 2, and multiply it by negative the square root of 6, and double it. And we're going to take the last term, including its sign, and square it. So we're going to take opposite of the square root of 6 and square it. So let's simplify that. Square root of 2 times the square root of 2 is 4. 3 times 3 is 9. 2 times 3 times 1 is 6. Square root of 2 times the square root of 6 is the square root of 12. Negative times itself is positive, and the square root of 6 times the square root of 6 is the square root of 36. Continuing to simplify, the square root of 4 is 2. Square root of 36 is 6. And 12, we can find a perfect square factor of 4 contained inside that. So break that down as the square root of 4 times the square root of 3. Continuing on then, 9 times 2 is 18. Square root of 4 is 2. And let's continue to simplify. 6 plus 18 is 24. Minus the 6 times 2 is 12 square roots of 3. So our answer, 24 minus 12 square roots of 3. Alright, now let me remind you something that you probably didn't pay close attention to in chapter 4. But it's very important in chapter 4 and chapter 5 and chapter 6. That when you have a plus b and this binomial a minus b, they're called conjugates. That the same numbers a, the same numbers b, not both of the signs are changed, but only the sign of the second number. If both signs were changed, if this were the opposite of a minus b, those would be opposites. But it's still positive a, and only the second one that's taken the opposite, and that's called conjugates. Remember from chapter 4, when we were multiplying conjugates, you can FOIL it out, but the outside, negative ab, and the inside, positive ab, drop out. So all you need to do is multiply the firsts and multiply the lasts. We did this forward, we did it backwards. Remember, we call that the difference of two perfect squares when we did that backwards. Alright, so let's multiply these two binomials. We have 2 square root of 3 plus 4 square roots of 5 times its conjugate, 2 square root of 3 minus 4 square root of 5. Since we reminded you, we don't have to FOIL. We only have to do the firsts and the lasts. So the firsts, 2 times 2 is 4. Square root of 3 times the square root of 3 is the square root of 9. And the last, positive 4 times negative 4 is negative 16. The square root of 5 times the square root of 5 is the square root of 25. Simplify that. The square root of 9 is 3. Square root of 25 is 5. 4 times 3 is 12. 16 times 5 is 80. 12 minus 80 is negative 68. Now, here's the important thing to realize. We multiplied two binomials containing radicals, and our answer at the end did not contain any radicals at all. That phenomena only happens when the binomials you're multiplying are conjugates of each other. That is very important, because as we started in our previous lesson, we still need to continue rationalizing the denominator. So let's revisit that. That means you have to get any radicals out of the denominator. And if that denominator is a binomial, what you need to do is multiply both the numerator and denominator by the conjugate of the denominator. That is the only way to get rid of the radical in the denominator. So in example 2, no, multiplying by the square root of 3 will not do that. That'll just give me 2 square root of 3 minus 3. And there would still be a radical in the denominator. So from the example we just did, and this advice, we know that the only thing we can do is multiply both the numerator and the denominator by the conjugates of the denominator. We must multiply by 2 plus the square root of 3 if we start out with 2 minus the square root of 3 in the denominator. And again, multiply both the numerator and denominator by that, because multiplying anything divided by itself is still 1. All right, let's multiply them out. In the numerators, we do the first, we get 2. Do the outside, we get 2 square root of 3. Do the inside, we get 2 square root of 3. Do the last, we get the square root of 9. Denominator, we know they're conjugates, so we're going to do the first, which is 4, and the last, which is minus the square root of 9. Continuing to simplify that, 2 square roots of 3 plus 2 square roots of 3 is 4 square roots of 3. Square root of 9 is 3. And in the denominator, the square root of 9 is still 3. And in the denominator, 4 minus 3 is 1. In the numerator, 4 plus 3 is 7. So my simplified answer is 7 plus 4 square roots of 3. And notice how we started out with a radical in the denominator and ended in simplest radical form without any radicals in the denominator. And that's our goal for rationalizing the denominator and putting everything in simplest radical form. All right, in example 3, we're back to functions. We have function f of x is x plus 1 over x, and they want us to find f of the square root of 2 plus 3. So translation, everywhere you see an x in the original function, replace it with 2 plus the square root of 3. Starting out with the numerator, 3 plus 1 is 4. Now we've got a radical in the denominator. We can't leave it that way. So we multiply numerator and denominator by the conjugate of the denominator. Only way to rationalize the denominator if it's a binomial is to multiply by the conjugate. So in the numerators, first gives me the square root of 4. Outside is negative 3 square roots of 2. Inside is positive 4 square roots of 2. Last is negative 12. In the denominator, they're conjugates, so the first is the square root of 4. I don't need to do the outside inside because they're conjugates. Last is negative 9. Simplify that, we will have our answer, so let's continue on that process. Negative 3 square roots of 2 plus 4 square roots of 2 is just 1 square root of 2. The square root of 4 was 2. The square root of 4 is 2. In the numerator, 2 minus 12 is negative 10, plus that square root of 2. In the denominator, 2 minus 9 is negative 7. And we normally don't like to leave a negative in our answer either. So if we multiply both the numerator and denominator by negative 1, this becomes positive 10 minus the square root of 2 over positive 7. That's our answer. And that's our look at multiplying binomials that contain radicals and rationalizing the denominator when the denominator is a binomial that contains a radical as well.